What you are seeing here is the combination of barium nitrate and glucose. When they burn, they create bright flames. Over the past year, I have experimented with various solid rocket fuels, exploring their properties and their capabilities. But here's the catch. None of the fuel I tried could consistently ignite and extinguish on command. That's when I realized there had to be something I can explore. I should be clear. We are dealing with some potentially hazardous materials here. Safety is key. This is not a step-by-step guide, but more of an inspirational peek into chemistry behind rocket fuel. I'm not advocating for anyone to try make explosives or doing anything unsafe. Don't try this at home unless you know exactly what you're doing. Now, onto the exciting part, the HIPEP fuel. This is a rocket fuel that can be ignited and extinguished rapidly, all by simply applying or removing electrical voltage. What's even cooler, it only ignites when connected to a power source, and once the voltage is cut off, it's out. Safe, controlled, and doesn't stay active when you don't need it. Let's jump right into the synthesis steps. First, we need to prepare a dilute nitric acid solution, using the nitric acid that I synthesized last year. Maybe I'll also make a video soon on how to make nitric acid. Then I pour the solution into an addition funnel. You can use a glass funnel to prevent any spills, because the reaction will create a lot of bubbles, so I used the addition funnel to control the dip rate. Next, I place barium carbonate into a beaker. The amount doesn't really matter. Just don't fill the beaker more than halfway. I don't want any bubbles to overflow the beaker. I drop in a magnetic stir bar and start stirring. Open the valve and slowly dip in nitric acid solution. The temperature isn't critical here, just to make sure the pH of the solution drops into acidic range. You can add a little extra nitric acid if you want to ensure the reaction goes to completion. It's easy to remove later. About an hour later, the pH of my solution have dropped to around 2. This means the reaction is nearly complete, and you will notice some white precipitate forming in the solution. Next, I let the solution stir for about 5 more minutes. Then I use a glass rod to scrape off any bubbles stick to the side of the beaker. Then I give the beaker a little shake to remove any unreacted reactants. After another 5 minutes, the reaction completely stopped. At this point, adding more nitric acid won't change anything, so it's time to separate product. Before I start the filtration though, I need to heat the solution to evaporate some of the liquid. This helps more barium nitrate precipitate out and gives me a higher yield, so I use a heater to boil off about half of the water in the solution. When you insert a glass rod and see crystals forming on the surface of the rod immediately, that means the solution has been successfully concentrated. At this point, I perform a vacuum filtration to separate the solid product. During the vacuum filtration, it is important to suck out as much water as possible. After filtration, I wash the solid with ethanol to help with drying later on. It is important to not dry barium nitrate totally with heat. It's a bit risky. Instead, I use the heater to evaporate some of the remaining water. Then, finish drying under vacuum at pressure below 0.1 bar. This way, I got a completely dry product.